Good morning, students. Today, objectives of elements of textile technology unit 1 are we are going to learn about what are the essential properties of textile fibers, what are the desirable properties of textile fibers, and flow chart showing the sequence of operations in processing a garment from a fiber. And basic process involved in conversion of fiber to garment, basic parameters of fiber measured for quality, basic steps in producing natural and synthetic fibers and filaments. So these are the today's objectives of today's objectives. So essential properties of textile fibers. So until about 100 years ago, all the fibers employed by man were from natural sources. Of all the natural fibers, only a few like wool, cotton, silk, linen have been very popular for textile purposes. This popularity can be attributed to some of the properties exhibited by these fibers. So these properties can be divided into two groups. First one is primary properties or essential properties responsible for the popularity. They are five primary properties. First one is staple length, strength, elasticity, uniformity, and spinning quality. And secondary properties which are desirable but not essential. So there are two properties divided. So primary also essential properties also called as primary properties, and secondary properties are desirable properties are also called as secondary properties. So first we are going to learn about essential properties. So first one is as I already told about staple length. So length staple length is used to express the dimension. That is length only. The fiber must be long and fine enough. This is basically because the two most important fibers, that is cotton and wool, are available with a definite length and fineness. The length varies in cotton fiber from 1.5 centimeters to 4 centimeters, and in wool 3 centimeters to 40 centimeters. Further, for blending, man-made filaments are cut into short staple or short staple length or staple fiber. This staple length should reach or match with the length of the other component fibers used in blending. Suppose blending is nothing mixing. So while mixing, the staple length of any fiber should be in equal length. In general, in particular fiber, the longer the fibers, stronger, and finer is the yarn. Similarly, finer fibers are more useful for soft, smooth, and uniform fabrics. For coarse fibers, higher diameter fibers, the fabric will be coarse and rough. So that is about staple length, which is very essential. Essential means compulsory. We have to you know see the quality of that fibers. Strength. It is essential that fabric should be durable enough. For durability, the fabric must be strong enough. The strength of the fabric is more influenced by the strength of the fiber present in the fabric. Also, stronger fibers can withstand the tension for its conversion into yarn and then into fabric. The strength indicates the resistance sustained by the fibers, the yarns or the fabrics to break when force is applied on them. The strength may be tensile strength, bending strength, bursting strength, tearing strength, etc., as per the direction application of the force. So, third essential property is elasticity. The third essential property of the textile fibers is elasticity. Elasticity is a property indicating the ability of the material to regain original shape after being deformed by the application of force. The desirable feature of any type of fabrics is that fabric must not distort its shape during its application. That means when we stretch the fibers, it should come to original place, but it should not break or the shape should not go. This indicates that the material should have a high elasticity. High elasticity increases high recovery from deformation. For example, 1000 meters of yarn is stretched to 1050 centimeters after applying some load to it. After load is removed, if the fiber measures 1000 centimeters, then it is said that the fiber has a elasticity 100%. But if the length after removal of the load is 1010 centimeters, then the fiber elastic recovery is 80%. But in the case the yarn is elongated to 1010 centimeters and the elongation is 1%. So it can be said that the elasticity opposes elongation. Elasticity or elastic recovery is generally influenced by the extent of stretch time during which material is kept in standard condition and time to recover. So that is about elasticity. Then uniformity. Uniformity of the staple is the fourth essential property. It is essential that there should be a limited variations in length and diameter between fiber to fiber. Or in other words, the fiber should be more uniform, which will ensure uniformity in the yarn as well as in the fabric. So, spinnability. Spinnability is a fifth essential property. It indicates the individual fibers must be capable of being spun into yarn and then a fabric with sufficient strength. For better spinnability, the force must have been better cohesiveness. Cohesiveness is of the group of the fibers. Group of fibers. Interestingly, spinnability term is commonly used in the case of man-made fibers manufacturing process. It basically indicates whether a continuous thread can be produced from the viscous material by extrusion and the thread can be hardened. So, a fluid is spiritable under given deformation condition with steady state continuous elongation of fluid. Jet proceeds without a break of any kind. Technically, higher the length of the thread produced, better is the spinnability of the material. These above properties were termed as primary properties, which are most common properties of popular natural fibers. So, these are all we learned that essential properties. What are the essential properties? Essential properties are staple length, elasticity, strength, spinability, and uniformity. So uh, these are the five essential properties. What are the five essential properties? Staple length, strength, elasticity, uniformity, and spinability. Now we are going to see desirable properties of textile fiber. Desirable properties are also called as secondary properties. So in this we are having elasticity, moisture absorption, density, color, luster, static electrical resistance. So these are all desirable properties. So once again. So desirable properties of textile fibers are elasticity, moisture absorption, density, color, luster, static electrical resistance. So elasticity. Elasticity is a property which the fiber tends to recover its original length upon the removal of straightening the deformation. So this is about desirable property. And moisture absorption. Moisture absorption means the absorption of water vapor from the atmosphere by the textile fiber which is kept in an open place. The moisture absorption capacity is expressed in the terms of moisture content, which means the amount of moisture content of the textile fiber and its original weight of fibers or its oven dry weight. And density. Density is the mass or weight of the material per unit volume, generally expressed in grams per cubic centimeter. Higher density fibers will produce higher weight fibers and vice versa. Then color. Most natural fibers have same color. Silk is slightly yellowish, cotton is creamy white or brown lint. Most of the synthetic fibers are creamy in color. Therefore, they must be bleached or boiled and stripped of the color by some chemical process in order to produce a white fiber and yarn as possible. Then about luster. Luster means shirting of the textile fiber. Luster means shining of the textile, that is brightness. Brightness or shining of the textile fiber. It is considered as an ornament rather than a necessary quality of the fiber. Silk fiber, rayon has more luster. Statistic electrical resistance, last one. The statistical electrical resistance creates problem in the spinning and other processing of textile fibers, especially in the very low relative humidity. This problem is more severe in the case of synthetic fibers because of low moisture absorption. Statistic electrical resistance creates a problem in sewing also. So these are the desirable properties we learned, that is elasticity, moisture absorption, density, color, luster, statistical electrical resistance. Next, so today's third objective is The flow chart showing the sequence of operations in producing a garment from basic fibers. So basic fibers, if you take cotton, that is cultivation of cotton, it goes to ginning. That means converting seed to fiber. Whatever the cotton ball is going to be there, from that the seed, the cotton fibers are separated from the seed. That is called ginning. Then it goes to we are going to remove the seed. The finally it is going to remain fibers. That is called short staple spinning, and from that the yarn is going to produce. The next process, weaving preparatory. That means yarn is going to convert into fabric. Then again that can be converted into weaving, knitting, non-woven. Then again wet processing, that is color or dyeing or printing can be applied. And finally garment manufacturing, that means creation of a garment is called. These are the flowchart sequence of the operations in producing a garment from the basic fibers. So cultivation of cotton to ginning, ginning to short staple spinning to weaving preparatory, then weaving, knitting, non-woven to weaving processing, that is chemical processing, and finally garment manufacturing. So basic process involved in the conversion of a garment. See, here I have shown the cotton ball and ginning, where they are going to separate the seeds. After separation of seed, how the cotton is going to look. Here I have shown the two. So ginning, after the cultivation of cotton, the cotton is picked out from the field along with the seeds. Hence, the first process is to remove the seeds from the cotton. Ginning is a process of separation of cotton and seeds from the lint. In this process, the raw cotton is passed between the rollers or a roller and a saw-toothed blades so that the seeds are separated out. This obtained cotton from ginning is called cotton lint. So here I've shown the cotton ball, and after separation from the seed, the cotton is going to shown here, that is called cotton lint. Then next, spinning. Second process, spinning. It is a process of converting cotton fibers into the yarns fibers in which the yarn into cotton. Sorry, it is a process of converting cotton fibers into yarn fibers into the yarn. It involves in various stages in which cotton is cleaned, fibers individualized and make a strand of aligned fibers and freshly twisted to make a yarn. Here I have shown the core cone wound yarn. See the picture. Then about third process, preparation for weaving. It, it, it involves the preparation of for weaving. The process involves in the preparation of warp yarn onto the beam, sizing to the warp to improve its strength, drawing in operations to pass the yarns through the heeled frames and reed, and gating onto the loom, and tying. Weaving is the process of manufacturing fabric by interlacement of two sets of threads called warp and weft. See in the diagram, the vertical lines are warp, that is blue lines, and horizontal lines, green color, that is called weft. So the interlacement of warp and weft yarns, we are going to get the weaving process. Next, knitting. Knitting is the process of manufacturing the fabric by interlocking of yarns. So I've shown here how the interlocking is done. So that see, you can see the observation, the difference between weaving and knitting. Here weaving is interlacement of warp and weft, one up and one down, like that it is interlacing. And here That is, warp and weft yarns are interlocking. This is the difference from weaving and knitting. Then next, chemical processing. Chemical preparatory processing. It involves treating the fabric under wet conditions to remove size. So after dyeing, after doing the weaving process, it will be in gray fabric. When the fabric is going to come from weaving process, it will be in gray color. So from that we have to remove the size, that is called desizing. In sizing we are going to apply starch to withstand the mechanical strain which comes in the machineries. So that size should be removed, that is called desizing. And removing natural wax impurities, that is called scouring. And making the fabric white, that is bleaching. By adding H2O to the hydrogen peroxide, we are going to get bleaching. And desizing is NaOH, and scouring chemicals are used in it to CO2 sodium carbonate, and bleaching we are going to apply hydrogen peroxide and improving the brightness of the fabric. That is masterization. So here I'm going to I've shown the color, different colors, and these are the fabric. Next, to textile chemical processing. It involves in the process of dyeing, printing, and finishing. Dyeing is a process of applying color. So in the previous slide, I've shown the colors. Here, these are the colors, and we are applying to the fabric. That is called dyeing. Dyeing is a process of applying color to whole fabric, whereas printing is a process of applying color as per the particular design. Finishing fabric is to provide market values to the fabric. By appearance of the fabric due to finish, we are going to buy. So here I've shown the dyed fabrics and printed fabrics. Then finally process is garment manufacture. So garment manufacture, this is a final stage where garment is manufactured from the fabric. This involves in inspecting the fabric from the buyer, preparation of garment patterns, laying the fabric, cutting the fabric, sewing, embroidering, fusing, pressing, and finishing. And finally, the outcome where the fabrics can be seen here, which are in hangers, which are in showrooms. They're going to display. So these are the basic process which are converting fiber to garment is again ginning, separation of seed, separation of cotton from seed, and this is spinning, converting fiber to yarn, and weaving, that is interlacement of warp and weft, and here knitting, interlacement, interlocking of warp and weft, or interlocking of warp and web yarns. And dyeing and printing. Chemical processing, here we are having the desizing, that is by applying HCl, NaCl, where it is going, size is going to remove, and the natural wax impurities is covering in sodium carbonate, the natural wax impurities are going to remove, and white, that is H2O2, hydrogen peroxide, and bleaching and moisturization. And coming to here, printing and dyeing, uh, applying color to the fabrics as shown here, and this is a printing. Printing is what? It is a process of applying color as per the particular design. And finally, garment manufacture, that means it is the first stage, when it's the final stage when the garment is manufactured from the fabric. And here in the display we can see the different types of fabrics. The next objective of basic parameters of fibers measured for quality. This is the fourth objective of basic of today's class is basic. What are the basic parameters of fibers measured for quality? After all this, we have to see the quality also. So the quality depends on the basic parameters are fiber length, fiber fineness, fiber strength, and fiber maturity. And the last objective, we go for first slide. What is the last objective? Basic steps in producing natural and synthetic fibers and filaments. So this is the last basic process. So there are two basic steps involved in production of synthetic or natural manufactured fibers. First one is polymer formation, that is polymerization. Then second is fiber formation. So what is polymer formation, also called as polymerization? Formation of long chain molecule by using monomeric compounds. Fiber formation is spinning, that is extrusion of polymer liquid through spinneret. Next slide. So these two steps can be entered natural or man-made, depending on which the fiber is called natural or synthetic or semi-synthetic. So in natural fibers, both polymer formation and fiber formation takes place naturally during the growth of fiber. Whereas in synthetic fibers, both these steps are synthesized using monomeric chemicals. In between these two categories comes the semi-synthetic fibers, in which naturally formed polymer is taken and the fibers are produced. So these are the natural fibers, cotton and jute, and these are the synthetic fibers. So synthetic fibers are man-made fibers. So I have given the picture here, that is man-made fibers are going to produce from the cellulose. Fibers can be natural or regenerated. Wool and cotton linters, main source of artificial or man-made cellulose fibers. New generation cellulose fibers made from sustainable wood sources. And after that, the this is the man-made fibers or yarns can be seen in this picture. So today's objectives completed. So finally we are going to review of today's class and we are going to finish. So slide by slide I'm going to tell. So today object is what we have learned. Essential properties. Desirable properties. Essential properties are what also called as primary properties. It is having staple length, strength, elasticity, uniformity, and spinnability or spinning quality. So staple length is used to express the dimension, that is length only. Fiber must be long and fine enough. And strength, it is essential property for your durability. The fabric must be strong enough. The strength of the fabric is more influenced by the strength of the fiber present in the fabric. Also, strong fabrics can withstand the tension for its conversion into yarn and then into fabric. Then about elasticity. This third essential property. Elasticity is the property indicating the ability of the material to regain the original shape after being deformed by the application of the force. Then fourth one, I think it is uniformity. Yes, uniformity is of the staple length is a fourth essential property, and it is essential that there should be limited variations in length and diameter between fiber to fiber. In other words, the fiber should be more uniform, which will ensure uniformity in the yarn as well as in the fabric. Spinability. Spinability is the fifth essential property. For better spinability, the fiber must be more cohesiveness. Interestingly, spinability term is commonly used in the case of man-made fibers, and it indicates that the individual fibers must be capable of being spun into yarn and then a fabric with a sufficient strength. And so that is about the essential properties, that is staple length, strength, elasticity, uniformity, and spinability. And coming to desirable properties are also called as secondary properties. In this, they are having elasticity, moisture absorption, density, color, luster, and statistic electrical resistance. So, so, so elasticity is the property of which the fiber tends to recover its original position. upon the removal of stress and causing deformation. And moisture absorption means absorption of water vapor from the atmosphere by the textile fiber when it is kept in open space or open place. In color, most of most of the natural colors have same color. Silk is slightly yellowish, cotton is creamy white, and synthetic fibers are cream in color. And therefore they must be bleached or boiled and stripped off of their color by some chemical process in order to produce a white color, white fiber or yarn as possible. Then about luster. Luster means shining of the textile fiber, and static electrolysis is creates problem in the spinning and other processing textile fibers, especially with the low relative humidity. And flowchart showing the sequence of the process producing a garment from the basic fibers. That is, first one is cultivation of cotton, from that ginning, then to short step spinning, then weaving preparatory, then weaving, knitting non-woven, then wet processing, that is chemical processing, and finally garment manufacturing. So that is the sequence, and then this is processes, basic processes. First one is ginning. That ginning is nothing but the process of separation of cotton seed from the lint. So here you can see the cotton ball, and after separation of seed, the cotton lint. Then spinning. Spinning is converting fiber to yarn. Weaving, interlacement of warp and weft. You can see the picture also. Knitting is a process of manufacturing fabric by interlocking or interlopping of the yarns. Then chemical processing. So in chemical processing, there are two processes, that is preparatory process and chemical processing. In preparatory processing, we are having resizing, scouring, bleaching, and mercerization. And in chemical processing and wet processing, we are having the dyeing and printing. And dyeing is not as applying of color. You can see the pictures to old fabric, and printing is the process of applying color as per the particular design. And finally, the process is garment manufacturing. It is the final stage of the This is the final stage where the garment is manufactured from the fabric. You can see the display, how the fabrics are displayed in the hangers in a showroom. And what are the basic parameters of fibers measured for the quality? That is fiber length, fiber fineness, fiber strength, and fiber maturity. And what are the basic processes in producing natural and synthetic fibers? So there are two basic steps involved in production of synthetic or manufactured fibers. First one is polymer formation, that is formation of long chain molecule by using monomeric compounds, and fiber formation is spinning extrusion of polymer liquid through spinnerate. Here you can see the before, see the pictures of how the man-made fibers are going to obtain. In natural fibers, both polymer formation and fiber formation takes place naturally during the growth of fiber, whereas in synthetic fibers, both these steps are synthesized using monomeric chemicals. In between these two categories comes the semi-synthetic fibers, in which naturally formed polymer is taken and fibers are produced. And you can see the natural fibers, cotton ball, and another example. And here man-made fibers. So generally man fibers are obtained from cellulose fibers, natural or regenerated. Wood and cotton linters are the main source of artificial or man-made cellulose fibers. New generation of the cellulose fibers made from sustainable wood sources. And you can see the picture of man-made fiber or yarns. So by this, these are the objectives today. we have learned. Thank you.